Hello. I think we're going to get started on time for once. I don't know. Seems like I think everyone's here, or almost everyone. But yeah, welcome to Hack Fukuoka July, and welcome to anyone online as well. I'm Laurie, Community Manager at the Engineer Cafe. I think I've spoken to everyone here at least once. It's good to see some new people, new faces, as well as some old faces too. Give me a round of applause all the time. And if you've not been here before, Engineer Cafe is a free co-working space, hacker space, maker space for everyone in Fukuoka, people who are engineers, want to become engineers, software, hardware, and everything in between. We've got this great space up here and a few spaces down below in the basement. And since many of our events are in Japanese, this Hack Fukuoka aims to be a bit of an English central point to the community. And we have a whole mix of people here. So just coincidentally, I think a few people had a few like hardware things and hardware topics they wanted to talk about today. So I've kind of rustled up a bit of a hardware theme to Hack Fukuoka today. But of course, who here has like done anything with hardware, like microcontrollers, sensors, anything like that? Yeah, a little bit. Who here is like, software is the only way? Yeah, okay. It's much cheaper, software. Right? So that's what we're going to talk about. Before we do, though, I just give a quick run through of events we've had and events that are coming up. So, well, what's been happening? It's a very hastily prepared list. Recently, we've had like a lot of electronics events. Nagashima, who's been doing these moku kai, which if you don't know is like a study meetup where you kind of bring along whatever you're studying and do some work on that. And we also had these maker streams from the basement on Wednesdays as well. And we also had this great API workshop, which you can find, I think the stream is on the YouTube channel from the talks. So that's what happened past month or so, or two. But coming up, always exciting to talk about, we've got Turtle Programming for Kids tomorrow morning. This is by Mark, who has been coming here about a year, learning about programming, teaching his kids about programming, and now he's kind of going to share that with everyone else. So that's going to be fun. First thing tomorrow morning at 10 a.m. Bring your kids. There's also the VR Challenge viewing party, which is going to be on Sunday morning, if I can remember what day of the week it is. Today, what is it? And Aaron's here from that. I don't know if you want to say anything about it now, or... Yeah, it's going to be a lot of fun, right? Yeah, and I'm sure we can all ask questions about it. Yeah, it's all themed about music, so we got some music demos, maybe some other demos. And hopefully maybe we'll do a kind of quick bit of demoing, messing around with stuff tonight, if it all goes to plan. Those are the big ones. Has anyone else got an event or a community or anything you want to give a shout out to? Anything like that? Nothing? Okay, I'm going to move on to the main talk. Main with quite a big asterisk, because it's just something I knocked up from what I've been doing the past few weeks. And this is the binary box. So I'm sure everyone here knows a lot about binary, but we get a lot of beginners here. So I thought it'd be fun to build a sort of teaching tool for binary. Inspired by a presentation by Adam, who's not here unfortunately. I think he's working out, he said. He said he might come late. But he gave a talk explaining hex and binary to kind of a popular crowd. And it was really good fun, but also like very mathsy, very wordy, lots of things on a screen. And I thought, that's cool, but I'd love to make something a little bit tactile that you can touch. I'd love to make something that explains binary kind of simply in a kind of fun way. And not just looking at a screen, because I'm looking at a screen all the time. And so I noticed the Raspberry Pi Pico in an electronics shop in Kaho Parts down in Imaizumi, just near Tenjin Station. great shop. They've got everything, so I recommend checking it out. And this is just a very, very simple, very cheap microcontroller, but it can do loads of stuff. You can hook it up to switches, sensors. You can do, they've made a Wi-Fi version on it recently. My version's the non-Wi-Fi version. So if you want anything kind of hardware, great place to start. And you can program it with MicroPython as well. So pretty straightforward. Too loud. Okay. So I bought one, bit of an impulse buy. And then I thought, well, I'm going to put it in something for my project. So downstairs we've got a laser cutter. And if you look at this image on the right is a laser cut storage box. Very, very quick and easy to make these boxes, and very, very cheap. And you can make them exactly the size you want. So I thought, okay, I'll make the project box, laser cut it, chop, chop, chop. You do have to calibrate it a little bit to get the cuts exactly right. But once you do, you can make something like this in a minute or two. And then what hardware did I put inside? Well, I got a couple of 7-segment displays lying around. I had a bunch of switches, these big kind of chunky power switches. And then I had a couple of dip switch for changing the settings. So, well, what did this all kind of become? Oops, oh, there's the code as well, sorry. The code is very, very simple. It's only a few tens of lines to just take the binary numbers and turn them into different representations to show on the screen. And well, what did I actually make? This is it. So basically, 8 switches down at the bottom, 8 bits, and then at the top it's an 8-bit number. And that's it. It's just a real little simple device. And I've added different modes. So it's got integers, unsigned integers, it's got binary coded decimal, it's got a float, 8-bit float, which is kind of useless, because there's big gaps between the numbers and things like that, and it's a bit buggy at the moment as well. But overall, yeah, it works, and it's a fun little project. Didn't take too long. I thought I'd do a little demo. Don't know if you can see it very well. I've kind of gone all out tonight with the cameras. Anyone got a favorite number? 9? You've got to tell me in binary, come on. 42? Okay. Go on then, tell me in binary. Let's try it out. So, you know, you get 16, what is it, 30? 42, must be something like this. Wrong off. There we go. No, 2, put a 2 on. Yeah, so for anyone who doesn't know, yeah, this is on the right, we're starting at 1, and then 2, and then 4, and then 8, and doubling, doubling, doubling. So of course the biggest number you can make, kind of, isn't it? You can make 255, and take it down to 0, all the good stuff. I have also done a bunch of these different modes. So if I can remember rightly, this is integers with a sign bit, right? So everything else is pretty similar, right? But then I added a sign bit. And if anyone can cast their mind back to their computer architecture classes, why is this not very good? Why is a sign bit not great for this? Yes. You get a -0 and a 0, which is not ideal, right? So if you're counting up, it kind of messes you up. So what do real computers use? Because this is mainly a teaching tool, right? Real computers use 2's complement, where this leftmost bit is -128, and then all the other bits kind of work just like before. And then I have 1, 0. I've got my minus numbers. Everything works great. And so on and so on. So I'm going to pass this around. Let me just put it back to regular binary numbers, unsigned. Oh, and yeah, you can kind of see the kind of laser cut. So getting the precision, I recommend having about twice as much material as you think you're going to need, so you can mess it up and not worry too much about it. Whoa. a bit more steady if I do this. Any questions? This is my presentation. Try it out. Yeah, any questions? Anyone want to ask stuff? Anyone on the stream? I don't know. No, no one's on the stream. Maybe they'll watch it later. Yeah, any questions, any thoughts, any ideas? It's all soldered. Just solder some wires into the pins. It's not too bad at all. Like it's the size. Raspberry Pi Pico is pretty easygoing with the soldering. I think if you're looking for like a first project, yeah, it's a microcontroller, so all the code is in the microcontroller. That's a battery, right? Yeah, you could plug it into any battery. You know, Raspberry Pi Pico will run off 3 volt, 5 volt. It's pretty easy going with that. I didn't mean to hide the insides. I just didn't want to. It's just a bit easier to switch everything on and off. Yeah. Yeah. It's very tactile, and the other thing that I noticed playing with this versus a computer is the response time on that is like instant. You know, you click a button and boom, it's changed. Compared to, maybe we're kind of used to a bit slow UI and a bit crappy UI these days. So, yeah, I'm not sure, but it does seem to react very quick. And yeah, pardon? Burn a little bit. Like, I mean, that's how it works, right? The laser burns everything. So I've never started a fire. I've never had a big problem or a fire or anything, but some people have. Yeah. Yeah, sometimes things can catch fire. Usually with wood, it's not enough to cause a problem, but it's enough to ruin the piece you're working on, like it cause burn marks and stuff. Yeah. Thoughts, questions, ideas, extensions, anything. Yeah, absolutely. Like, I think that'd be a nice variation to. Yeah, you could have you could just have one counter button and then a row of LEDs counting up in binary or something like that. I think so. We're doing an event on Tuesday, which is for kids about binary and computer science. I think we're going to do a bunch of activities, but towards the end, I'm going to challenge them to make numbers on this. Like, come up to the stage. Can you make the number? Maybe cover up the screen. Has he got it right? Ooh, it's kind of an exciting moment. Yeah. Oh, yeah, the Raspberry Pi Pico, that's one of the bigger ones. You can get these ones so in fact, and that's at 2 cores as well. Like, you can do inference on that, you know? Let me show you some more. Like, oh, thank you. Yeah, just put it there. So here is, we've got a box of these. It's pretty small, isn't it? This is another one. So this has Wi-Fi. This has an accelerometer, maybe you can see. It's got a microphone, it's got an LED. On the edge, it's got connectors, so you can plug in peripherals, so these are all your kind of input, outputs. You've got a couple of buttons, so you can develop something straight onto this. So it's got like a real-time clock. This is a little microphone demo. A little bit. I'll pass this around as well. But this is part of the M5 stack. And we have a bunch of these. I've got this one which doesn't actually have a program running on it at the moment, but this is a slightly bigger one with a beefier screen. And again, same thing, input and output pins on the edges, a bit hard to see. So you can plug in any kind of electronics you like. Oh yeah, it's got infrared. It's got Bluetooth. And these are all free to use here at the Engineer Cafe if you want. There is actually a contest of like who can make the coolest thing with M5. So if anyone's interested in entering the contest, I'll definitely support that. Give you some tips, ideas, willing to help with Japanese stuff if you're kind of not so confident in the Japanese. But yeah, pass this one around. I'll pass that one around as well. It doesn't do anything. It's a bit, I couldn't get a program on in time. Yeah, what else we got here? Yeah. Yeah. Kind of, but it's a bit broken. I didn't manage to fix that in time. So it just changes the mode. So this is a positive integers right now. Yeah, but it also does negative integers, floating point, BCD. I was trying to think of 8 different representations. I could only come up with about 5. Octal, yeah, you could do octal, you could do hex. I thought unary might be quite good. Just show how bad it is, right? Like counting, 1, 2, 3, 4, 5, 6, 7, 8. 5 bits. Yeah, you could do a 5-bit number. What would you do with the other 3 bits? That's the question. But, yeah. Ternary. Oh, yeah. How do you represent it on a digital microcontroller? Well, I guess you could use like 3-way rocker switches, couldn't you? Yeah, yeah. I like it. So that's everything I've got to talk about. Anyone got any ideas about microcontrollers? Yeah, that one's pretty small. The M5 stick, I think it's called. But there's some even smaller ones. The M5, they call it stamp, like a postage stamp, and it's about the size of a postage stamp, no screen. And if you want to go really small, you can get the kind of 8-bit microcontrollers, the AT Tiny, which, you know, they're fingernail sized. But they'll do 20 megahertz. And they don't do float or anything, but they've got inputs and outputs, and they'll do most of that stuff. When you mean ports, do you mean the input-output ports or the pins? Yeah, I mean this one, the M5 one comes with a bunch of little cables, if you want to take a look. Whoop. But so basically everything, it's just wires, right? So if you've got, I don't know, a LED, you could wire it up to that. Or if you've got a light-dependent resistor, you could hook it up there and have like an analog signal going in. Or if you have other devices, there's various different communication protocols like I2C and UART and SPI and stuff to help different devices communicate and do measurements. So these guys will support all of that. You know, it's all very easy to get going. Yeah, it comes with a watch strap. So if you want to do a smartwatch, very straightforward, yeah. Yeah, cool. Yeah, so that's like all the really, really planned stuff. But I know, Aaron, you were talking about doing a volumetric video tonight. You reckon you can do it? Yeah. I got the recording replay working, but okay. I couldn't implement the rotational, all the stuff for AR. Oh, I see. So I'm working on that. Okay. Maybe not tonight then. Okay, maybe. Sure, yeah. Yeah, yeah. Please do, please do. Yeah, if anyone's got any things they've been working on recently or anything you want to show, it's very much a show and tell here at Hack Fukuoka more than anything. Yeah. Have we got a cable long enough? Stream, and so people can watch a recording of this afterwards. But if anyone wants to jump in with some stuff, or people who are here for the first time, like tell us about what you're doing at Kyushu University, that might be interesting, or your companies and projects. Go ahead, yeah. Let me pass the mic around.
Hi, I'm Mizuki Yamamoto, and I'm not good at English, so maybe I can speak fluency, so maybe I make you guys more, but okay.
Before that,
Okay. Sorry. Okay, I'm working. I'm doing the job for kind of freelance. Is it? And I'm making the applications using Flutter because Flutter is so easy to create many apps. It's so productive, and it's because it can make the one single code two different OS applications, such as iOS applications and Android applications, and also Mac OS applications and Windows applications, and also website. Flutter can make websites, so I'm using that Flutter. Yeah.
I think you're hiding the best part. The best part is you wrote the Engineer Cafe front desk software in Flutter, right?
Yes.
So let's get a demo of that. Hopefully no one comes. Anyway, I could plug this in, sure. Yeah, go on. Tell us about the Engineer Cafe software.
I created these applications, and before we use this software, when the user engineer cafe user came here, we write the form, a kind of Google form. Google.
Yeah, originally it was all just Google Forms, like really, really cobbled together with Google Forms, and it was okay and it worked for the beginning.
Yeah, but it takes too long time to write the form, and so I created this application, and how to use it. I'm gonna introduce how to use it, and some user came to here. I write the user's number. So my number is 00.
So everyone who signs up for Engineer Cafe gets a membership number.
Yeah, membership. Thank you. If you write the membership number, the member's name came here, and I can say, "Hello, Mr. Mizuki-san. Hello, Mizuki-san." And where do you want to? Which room do you want to use? And he said, "So I'm gonna want to use the main hall." So just click the main hall, and it means use, and just click, and just done. Yeah, it's so easy and so simple. You can see the whole rooms and which room is used. You can recognize about all things, and and if you some people came to, I don't know I don't remember the number, so you can search it here, the name, a phone, email. You can sorry, I didn't fix this function, so I should. I'm doing this one, but yeah, usually you can search about the name and figure out the number. Yes.
Great.
Yeah, kind of this stuff. Yeah, it is created by Flutter.
Yeah, really, really nice stuff and very practical and useful, and it makes our work a lot easier at the Engineer Cafe. And I don't know if you mentioned the back end is Firebase, kind of real-time database as well. Yes. Any questions about this one?
I've never worked in Flutter.
Yeah.
What is the development environment like? Can you show me how you work in Flutter?
The source code?
Yeah.
Okay. I usually use the VS Code, and
Or is it not
can
on
I
this computer?
bring the
If you want.
my
Yeah,
PC?
go ahead. Cool. Anyone used Flutter here? Anyone? Yeah, I think it's another one of these cross-platform things where, I tried React Native a few years ago. I wasn't sure if it's more work or less for trying to make cross-platform things, but Flutter's getting more and more popularity. There is a Flutter competition with a grand prize of, I think, 100,000 yen, run out of Osaka. They did a React competition a few months ago. So if you're interested in Flutter, I think that's a good competition to try and enter. And the theme is shopping and shops. So anyone wants to do that, speak to me later. Is it looking okay?
So this is the Flutter's IDE, and the code is kind of here, and the file name is /dot, and because we Flutter use the Dart, so I will debug this program, and also we can use the platform, the debug platform from here. And also, if you connect to the smartphone, to the PC, you can choose your own smartphone. Yeah, and so please wait a moment. I'm not just Flutter. I use the Firebase. Yeah, yeah. Yeah. You can use, yeah, create the API, and yeah, you can use it. And
Yeah, so most people are using Flutter on like mobile, aren't they? But I think the web side of things is getting better and better all the time. So we don't have a mobile app for the front desk. It's just the web app.
so this is the screen, and sorry.
Sorry to put you under so much pressure of doing a demo that you didn't think you were going to do.
So okay. This is actually the Engineer Cafe's managing page. Yeah, and the Flutter is so productive because if you change the code, you can see immediately. So, for example, I want to change this main hole name, so I'm gonna wait a minute. Here is the main hole, the room title and the main hole. It's related to here, and if you change to English main, is it right? Okay. And this is a hot reload command, and wait a minute. Yeah, it's changed it to English immediately. So the feedback is so fast. So if you can test many tons of UI. So yeah, so it's so speedy to make the applications. That's the Flutter's good reason, but part of one good reason. Yeah. And it's easy to connect to the Firebase because the Flutter show us about the document how to connect to the Firebase, and yeah, it's so useful. Yeah.
Cool. Thank you so much. I think a great round of applause for an impromptu talk about Flutter and the software we use here. Yeah. Because the database is all in Firebase, we have thought that in the future it'd be really cool if we could use some of these and interact with Firebase or make a new API, have some hardware stuff, have some software stuff. If you have any ideas or you want to make anything, please talk to us, because we want to kind of push forward with the idea of kind of the engineer cafes built by people who come here, not just sort of doing off-the-shelf stuff. Yeah, awesome. Do you reckon you're going to manage to do some kind of demo? Oh, fantastic. This is great. Oh, thank you so much as well. Thank you. Woo. Okay, let's see if we can get this next one going. Which cable are you on? Do you want a microphone so we can have the recording? It's gonna have to go around.
Hi, everyone. So a lot of stuff that we do at Steampunk Digital is 3D scanning and holographic communications. What we have here is XMeet, and it's two parts right now, where we have a sending application. It's this one. And so, hello. So what it does is this app is using the true depth camera on the iPhone to capture a 3D data and then encode that live into a call session. So I'm just going to put the microphone down and I can mess around with the viewpoint. Oh, so you can see, you know, when it's off axis a little bit, you can see how it's 3D. And so we can also change like the depth range that we're encoding. If we have it set too near, then it'll clip stuff that's too near. So you want to find like an optimum kind of range that's like captures the essence of you and cuts everything else out. It's also a live audio video. Check, 1, 2. now is that we're starting to do real-time transmission of the tracking as well. And the result is that you can see that this is showing kind of representation of the table. But with the tracking now, it will stay physically still. It won't move. I don't know why it's not working right now. It should just work. The tracking.
What do you mean when you say it stays physically still?
So this, unfortunately, I can't really demonstrate here because it's not working. But the idea here is wherever my phone moves, the AR representation of it, 3D representation, shouldn't move.
Oh, so it like compensates for the camera movement?
So the camera's moving around the table space. I don't know why it's not doing that right now. It should be stable.
Cool. Thanks. Thanks for giving us a bit of a sneak preview of what we might be able to see more of on Sunday morning. So yeah, Sunday morning, 10 a.m. VR challenge viewing. Hopefully we'll get more demos like that, sound and music demos, lots of headsets.
Right. So about that.
Oh yeah.
So here's the app that we're going to have here for Sunday. And all it does really is...
I think your mic's off here.
Right. So what it does here is it's just a recorder. It's recording audio, video, and so I'll just start the record here. Daisy, Daisy, do 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 do. Okay, I'm a terrible singer. I need more karaoke practice. Okay.
So that's a full sound and volumetric video?
Yeah.
Nice.
So now I can take that. Oh.
Hold the mic up.
Do 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 do. Okay. I'm a terrible singer.
Amazing.
I need more karaoke practice. So this is now recorded as a payload. I can load into, say, Quest. So I can load this into Quest and then, or like an iPhone app or something, and then just use our tools for playing that capture. So
Cool.
that will just be a performance in 3D. So.
Nice. Well, thanks for all that. Yeah, thanks for your demo as well.
No, it's actually pretty. So the question is there any interpolation going on, kind of guessing where the other side of the face is? I know it's just because I'm holding the camera about this far, but our understanding of perspective is kind of a tricky thing. So the camera is far enough away that it's recording what would be like a 3D impression of my face, but then it's projecting it much closer. And our eye thinks that due to perspective that you wouldn't see that side as much. But actually because, if you come in with a camera and you zoom in from a distance, you actually get more of the one side of the person. So yeah, it's kind of neat, like holographic capture and then replay. You can get pretty far. But there's also some new AI processing techniques, and I really want to do some of the real-time holographic reconstruction on the far side. So there's maybe I got to do a little demo of PyFu to show what's possible there. It's pretty amazing. Like it really guesses the backside and clothing and stuff.
Nice.
It's pretty wild.
Cool, thanks. Yeah, I think maybe if everyone has said something, everyone who wants to say something has said something, I might cut off the stream there and then we'll just hang out for another 30, 40 minutes and see what everyone's up to. But yeah, thanks to anyone who's watching online, and thanks for people presenting as well. I'm really glad somehow we managed 3 cool little presentations out of no planning, so that was great. Yeah, thanks a lot. Bye. There's no camera.